Welcome to all of you, and this is the fourth lecture on nucleophilicity and basicity. In the last three lectures we had seen the theoretical aspect of nucleophilicity and basicity. In this last lecture we will try to concentrate on few examples which may appear in competitive examination. In order to solve these questions, in order to understand these questions, in order to get confidence while you solve this question, you must go through the previous three lectures, which will give you a conceptual idea, a conceptual clarity related to nucleophilicity and basicity. With that understanding, now we try to solve few questions here. The first question: fluorine, fluoride ion, bromide ion and amide ion and carbon ion. They asked what is least basic here? What is least basic? Among these four, which is least basic? If you consider fluoride, amide and CH3, these all lie in the same period. Carbon, nitrogen, fluoride, and we know across the period basicity decreases. Therefore, among these four, fluoride ion is the weak base, and quite naturally, fluoride and bromide are the members of same group. They are the family members of same group, and we also had seen in the previous video, down the group basicity decreases. Across the period basicity decreases, and down the group basicity decreases. And since boron lies at the down of the group, therefore for this question, Br minus is the weak base. Br minus is the weak base. This is the question. This is the first question. I hope this is clear. I repeat once again quickly. Across the period basicity decreases, therefore fluoride ion is the weak base. Down the group basicity further decreases, therefore bromide ion is the weak base. Therefore among the four, bromide is the weakest base. So now come to the second question. In this second question, they had given you ethoxide ion CH3 CH2O minus, and they had given you sulfide, and lastly they had given you carboxylate ion. And the question is, they asked nucleophilicity decreasing order. They asked nucleophilicity decreasing order in, look at the solvent, it is polar protic solvent. As soon as you see polar protic solvent, your brain should scream, in polar protic solvent salvation is possible. Smaller the anion and it is solvated largely. Therefore, polar protic solvent salvation is maximum. When salvation is maximum, size of the group increases. When size of the group increases, group becomes bulky. Bulkier group is the bad nucleophile. Therefore, I will write here, bulkier group is a bad nucleophile. Bulkier group is a bad nucleophile. Therefore, among these three, what is the nucleophilicity order? Decreasing order. And we already know down the group nucleophilicity increases. Down the group nucleophilicity increases, and bulkier the group, it is the bad nucleophile. So for oxygen, sulfur lies below the oxygen. Therefore down the group nucleophilicity increases. Therefore the first one is, suppose if I label them as 1 and 2 and 3, second one is the strongest nucleophile, which is followed by 3, which is followed by 1. Now a question arises between 3 and 1. Why? Wait for a moment. This is not 3. 2 greater than, 1 greater than 3. Third one is the weakest nucleophile because it is stable. It is stable because of resonance. That resonance decreases its nucleophilicity. Therefore, that one is the weakest nucleophile, followed by second one, and the second one is the strong nucleophile. Second one is strong nucleophile. We used concept called down the group nucleophilicity increases. And we also should remember bulkier the group, nucleophile is bad. And you also should remember polar protic solvent always leads to solvation. Solvation increases the size of an ion. I hope these two questions are clear. Yes, I feel they are clear. If they are not clear, just try to listen one more time. By listening them again and again, something within you opens up. Something within you opens up, and you already know practice makes anyone perfect. Practice makes anyone perfect. But we just need some interest and some enthusiasm. That's all. Nothing matters. Nothing matters. A little enthusiasm and little interest is more than enough. Suppose if they give you OH minus and SH minus, and if I ask you nucleophilicity order in PPS and basicity order, basicity will not change depending upon the solvent. So nucleophilicity in PPS and basicity in PPS, look at them. First of all, ask a question to yourself. Do they belong to same period? Do they belong to same group? So your brain will say they belong to same group. And ask yourself, down the group nucleophilicity in a polar protic solvent. In a polar protic solvent, nucleophilicity increases. Nucleophilicity increases as you see. Ask yourself, if polar protic solvent is present, so what it leads to? It leads to solvation. Nucleophilicity, bulkier the group, nucleophilicity decreases. Therefore, nucleophilicity of SH minus is greater than OH minus. Whereas the basicity down the group decreases. Therefore, OH minus is greater than SH minus. The one way to understand this quickly is to go through the previous videos as many times as possible. Yes, in organic chemistry, few concepts confuses. But yes, you are more intelligent than organic chemistry. Your mind is more powerful than organic chemistry. Organic chemistry is far, far below than your mind. Organic chemistry is not ahead of your mind. Organic chemistry is the follower of your